That's a lot, a long time to be weather aware, and even this summer and early fall, we can still have tornadoes. Though at that time of the year, it's usually due to landfalling tropical storms and hurricanes. This is the map showing the number of tornadoes that have happened by hour of the day. We see, again, not too surprising that the peak time for tornadoes is late afternoon, around 4 or 5 o'clock. But again, we've had tornadoes and many tornadoes at all hours of the day and night in central Alabama. And we especially want to be aware of all the tornadoes that happen in the middle of the night around here. That's very dangerous because people are sleeping. They may not hear the warnings. It definitely shows the importance of having a way to get warnings that's going to wake you up. Things like outdoor sirens or the TV won't really help you wake up in the middle of the night if there's a warning. You need a weather radio or some other types of apps and alerting systems to get that warning in the middle of the night and always be prepared. Now, on the left is a map of Alabama with the number of tornadoes that have happened in each county. Now, there are some big caveats in this type of map. First off, the larger counties are typically going to have more tornadoes just because they're a bigger target. And also, more populated counties, it's more likely that a tornado happened and was reported. Some of the more rural counties, especially going back in history, a lot of times there was probably tornadoes that happened that we never actually heard about because they're weaker and just weren't reported. Whereas something hits in a populated area, we're going to hear about it. Now, we are starting to get better at finding out about these tornadoes in rural areas because of things like tornado debris signatures on radar, and social media has been huge. Everybody's on social media letting us know if they have damage, so that does help. So that in mind, we do see quite a bit of tornadoes that have happened in the northern part of the state, but anywhere you go in Alabama has had a tornado. And also, you see a lot of tornadoes down by the coast. That's due to hurricanes and also probably some water spouts as well. Now, we rate tornadoes kind of a scale of 0 to 5 based on the damage that occurs, starting with EF0 tornadoes are the weakest tornadoes and EF5 are the strongest. We do see that the majority of tornadoes are relatively weak, EF0 and EF1 tornadoes. But you still want to keep an eye on those. While as the stronger tornadoes, EF2, EF3, are a little bit less rare. And EF4 and EF5 tornadoes, the stronger tornadoes, are thankfully the rarest type of tornadoes, though these do cause the most injuries and fatalities. All right, this is the map showing kind of the breakdown of injuries and fatalities by EF scale. Again, EF0, EF1 tornadoes produce very little in the way of injuries and fatalities. And then as we get to the stronger tornadoes that are also more rare, we do see that these do cause a lot of fatalities and definitely need to be taken seriously. All right, so what kind of severe weather information is out there and how do you get it? Starting off kind of further out in time, when there's severe weather expected within the next 7 days, either today or tomorrow or a few days from now, there'll be what we call a severe weather outlook. Now, there's national outlooks that are issued by the Storm Prediction Center in Oklahoma that cover the whole country and show generally where the highest threat is. Now, with these covering the whole country, there isn't going to be a whole lot of fine detail in these, just showing kind of a broad depiction of where the worst severe weather is going to be and how bad it's going to be. And then when we do expect severe weather, we'll issue what's called a hazardous weather outlook. And as we get closer in time, we'll start issuing these graphics that are severe weather impact graphics. They'll help show what areas are at risk, what is the risk, and when is it going to happen. And so when you see these, it's really good to know, figure out where on this map that you live, and just be ready even now to start thinking about, okay, where am I on this map? What county am I on? What interstate am I near? Or what cities? Great question on the SPC graphics. Their webpage is spc.noaa.gov, and they also post it on some social media feeds. And then going back to our local graphics, again, these are zoomed in on central Alabama. You may see some small differences between them and SPC. That's because, we're kind of looking more at the fine details. We're just focused on central Alabama, and we kind of have some local knowledge of the area to know more about the threats and how much of an impact this will be to the area. So we'll talk a little bit more of the categories later. We can see here the yellow shaded area would indicate, in this example, as slight risk at Hamilton, Tuscaloosa, and Birmingham. And the green shaded area is in a marginal risk in this example. Areas like Clanton, Anniston, and Gaston. And this outlook, the areas that are kind of not shaded at all, like Montgomery and Auburn, Troy, and Eufaula, they would not be in a severe other risk, but we still want to keep an eye out in case these forecasts will change. Time up here would tell you that time to be aware of severe weather, in this case, 1 p.m. to 9 p.m. And then we have the information over here letting you know what the threats are. In this case, tornadoes, hail, and damaging winds. And so you find these on our webpage, weather.gov/BMX, and we'll post these all over our Facebook and Twitter pages. All right, so here's how to understand the different severe thunderstorm risk categories. The first is just for general thunderstorms. Now, in this case, this kind of outlook is something you see in SPC's page. You wouldn't see it in our outlooks as much, but these are pretty common, that there's thunderstorms expected. And one important thing to remember is that even if severe thunderstorms aren't expected, as far as any hail, damaging winds, or tornadoes, all thunderstorms can and do produce lightning, which is dangerous. And a storm does not have to be severe or even have a lot of lightning to potentially be deadly. So anytime you see lightning or hear thunder, you want to go indoors. So the first risk category then is the marginal risk, or 1 out of 5 risk, which you might see as a kind of bright green. This indicates an isolated severe storm or two are possible. Typically, it's going to be pretty short-lived, pretty isolated, less intense. This kind of a case where we can't totally rule it out, with some low-end strong damaging winds, a little bit of hail, and a brief isolated tornado. So we move up into the yellow shaded category, a slight risk, level 2 out of 5 risk, indicates scattered severe thunderstorms are possible. This is kind of your standard severe weather day, where there will be a chance for some severe storms. They won't be as widespread, but they still could be locally impactful, and you could expect the potential for a severe thunderstorm or tornado watch to be issued in that day. So move up to the orange shaded category. That has an enhanced risk, or level 3 out of 5. This is when you really got to start paying attention, because numerous severe storms are possible, including some strong ones. Storms are going to be more persistent and widespread, a few intense. More widespread tornadoes, and some could be strong. More enhanced wind damage, and some larger hail. The red shaded category is a moderate risk, level 4 out of 5. We're getting to a more higher end type risk that's more rare. Really got to pay attention on those days. Widespread severe storms are likely. And the worst category is the high risk, kind of this magenta color, level 5 out of 5 risk. These are pretty rare outlooks, relatively speaking, indicating more of a severe weather outbreak. These are type of outlooks you might see on April 27, 2011 type event, and definitely days you got to be very careful. Okay, a good question about how to tell if there are tornadoes at night. That's definitely a big challenge because at night you're not going to see a tornado. In our case, we'll be relying solely on the radar to try to determine where a tornado is, and then hearing about damage. But these are cases where we would not encourage any sort of storm spotting. Outside at night, you're not going to see it, so if there's a warning, you want to go straight to your safe place, and then let us know afterwards if there was any damage. Now, as we get closer in time to the severe weather threat, we switch over to the watch phase. It's really important to distinguish between a watch and a warning means. A watch is kind of shaded in yellow here to indicate this is that kind of a caution type stage. This is when the conditions are favorable for severe storms to develop anytime between now and the next few hours. They're issued for a fairly large area, several counties, and valid for a few hours. In this case, this tornado watch was issued for southern Mississippi and eastern Louisiana. This means conditions are favorable for severe weather to develop, cover large areas, and last several hours. You'd want to be aware and be prepared. When a watch is issued, you want to start, okay, what's my plan going to be if a warning is issued? And you don't want to be necessarily caught somewhere where you're not going to have time to get to your safe place when a watch is out. This is not the time to go for a hike in the woods or anything. If you do live in a structure that's more vulnerable to severe weather, like a mobile home, manufactured home, camper, kind of this phase is when you may want to consider getting closer to a sturdier shelter, whether it's the neighbor's house, a storm shelter, some other safer place, because you don't want to wait until the warning is issued to be getting out in your car and driving somewhere. Finally, we'll talk about severe weather warnings. When a warning is issued, that means that severe weather is either happening right now or it could happen any second, any minute now. And they cover small areas. They cover areas smaller than a county oftentimes. So, for example, people in this northern part of this county, they're fine. They're not in the warning. But down here, they are in the warning. So they're more targeted. And so if you live in this area covered by the warning, you need to not wait, but immediately take action. Get to your safe place. Don't be caught outside. Don't be caught in your car or in a mobile home. Oh, great question asking about what a derecho is. It's probably a term that the media's kind of caught on to a little bit more in the last couple of years. It's been around for a while. Derecho is a case where you have a line of storms with damaging winds that travels for typically hundreds of miles, where you have continuous damaging winds for hundreds of miles, and some embedded spots of more significant wind damage, winds greater than like 70 miles per hour. Just a better way to describe a widespread damaging wind event. And there can also be isolated tornadoes with those too. All right, so let's recap kind of the timeline between severe weather forecasts and warnings. So leading up to the event, you're going to see some outlooks issued, different risk categories, marginal, slight, enhanced, high. Don't get too caught up in the exact category. Just know, hey, I need to be aware of this day. There could be some severe storms that day, and I'll be ready. When we get to the day event, first the watch is issued, indicating conditions are favorable for severe thunderstorms. So it doesn't mean you have to get to your safe place right away, unless you're far from a safe place, but it means you need to be very aware of the weather. Finally, the warning is issued. Now's the time to act. Severe thunderstorms are occurring or will very soon. So don't wait, get to shelter. Another person asking about what to do if you live in a not very tornado-prone area and don't have a plan. If you live in Alabama, I mean, you're in a tornado-prone area, first off, but no matter if you are outside Alabama, wherever you are, you want to have a plan in place. And so hopefully tonight can be an inspiration for you to have that plan. We'll talk a little bit more about sheltering later on, but you want to go ahead and start thinking about this now. You don't want to wait till the day of the event. All right, and we'll talk a little bit more about tornado safety in the next few slides. All right, so what is the definition of a severe thunderstorm? Some people aren't always aware of the exact definitions. A storm is considered severe if a thunderstorm has wind gusts of 58 miles per hour or greater, which is enough to begin to do a lot of damage to trees and buildings, and or hail that's 1 inch or more in diameter. Now, if a storm has a tornado, it's also severe, but instead of a severe thunderstorm warning, we'll issue a tornado warning instead. But even with severe thunderstorms, you want to take those seriously. Trees can come down on your house and be very dangerous, and so you definitely want to be inside a sturdy structure if those are issued. And occasionally, severe thunderstorms can produce tornadoes with little or no advanced tornado warning. On the flip side, a storm with a tornado warning can also have damaging winds and large hail. Now, the amount of lightning a storm has does not determine if it's severe. A storm can have lots of lightning but not be severe because that doesn't have either the winds, the hail, or the tornado. But any storm that has lightning, of course, you should still move indoors, and it's still dangerous from that perspective. All right, now we'll talk more about how to report severe weather and what types of weather to report to us. Never assume anything. Don't assume that just because a warning is out is that we know that severe weather is happening. So basically, don't think your report is important. We want as many reports as we can of severe weather. Just the more data we get, more info really helps us with our warnings. So anytime you see severe weather, go ahead and report that to us. Also, be quick with your report. Severe weather is time sensitive. Get a report to us right away. Even if the storm's past your house, the storm is probably heading towards someone else's house downstream. And so by you putting your report to us, actually helps out your neighbors downstream. And you want to keep your report short and just think about telling us the what, the when, and the where. Also, one warning is to never exaggerate your report. Unfortunately, it's difficult for us, but we do face problems of exaggerated or fake reports that we're trying to sort out. So really help us out and give us as much detail to your report. And be careful of the choice of words and descriptions you use. If you're not quite sure what you're seeing, it's okay. Let us know that you're uncertain. I might see a wall cloud, might see a tornado, but I'm not quite sure. That's okay. And we really appreciate you being as honest with us as possible. All right, so what kind of severe weather should we report? Probably the most common thing you report to us in Central Alabama is damaging wind. We're not just trying to report tornadoes here. Now, we want to get these reports of damaging wind. Often, that's going to be any sort of trees down. Now, sometimes, we'll ask if there's any damage somewhere, and they'll say, oh, well, there's no damage. We have lots of trees down. Well, we want to know about the trees because those trees can fall on a house, fall on someone, and hurt them. And so we definitely want to know where trees fell. Now, it can be pretty hard to estimate the wind speed. For a storm to be severe, that has to have 60 mile per hour winds. It's really hard for you as a person just looking or feeling the wind to actually know what the wind speed is. Now, if you have, a wind sensor or weather station, that's great. Let us know what that wind speed is. Otherwise, though, you want to focus more on what the effects of the wind are. And so a lot of times you're going to report to us, again, damage. Whether it's trees down, power lines down, shingle damage, fence knocked over, any kind of structural damage. If you do report a wind speed to us, make sure you let us know if it was just something you estimated or actually was measured by some equipment. So report to us, trees and large limbs that are blown down, and tell us a little bit more about the trees. Were the trees snapped off? Were they uprooted? which could be impacted by things like wet ground. Right now our ground's pretty wet. Trees are going to be uprooted pretty easily. We also want to know, hey, are these big, strong, healthy trees, or are they, flimsy trees, or are these dead trees? A lot of times, dead trees that are around, they're going to fall a lot easier with much weaker winds. We also want you to report hail to us, especially not just that it's hailing, but we want to know what size the hail is. We want you to report the largest hailstone that you see. Of course, do that safely, of course, because that's going to be the size that's doing the most damage. The best way to measure hail is, of course, with a ruler. But if you don't have a ruler available, try to compare the hail size to common items that have a standard size. Coins are really good. You could tell us you have dime size, nickel size, penny sized hail. And then quarter sized hail is when hail becomes severe, 1 inch. So letting us know if hail is quarter inch is the size of a quarter or more. And bigger hail, you get $50. If you get to even bigger hailstones, try to reference it compared to different sporting equipment. Is this golf ball sized hail, tennis ball sized hail, baseball sized hail? Let us know any damage that was done. And of course, just be safe with this. One thing we want to be careful is, please don't report marble sized hail to us, because marbles can actually be a variety of different sizes. We don't know if these small marbles, large marbles. Use something standard, again, like a coin or a sports ball. Also, you may not think about it, but we also need storm spotter reports of flooding. We've had a lot of that recently. And we want as much descriptors of the flooding that you can give us. Is this out in a rural area? Is that an urban area? We want to know how deep is the water. And also we want to know, hey, is this water just standing water, just some ponding, a large puddle, or is this water rapidly flowing across the road? Because that's going to be a little more dangerous. The flowing water is going to be more dangerous. If you have a creek that's running across the road, that could potentially sweep people and cars away and be more dangerous. Let us know if there's any damage. And overall, hey, is this flood water life-threatening? Again, if it's really deep, deeper than a person, or if it's flowing fast, that is life-threatening. And where is the flooding you're witnessing? And also, hey, is this an area that floods every time it rains, or is this an area that you've never seen flood before? That can really help us get an idea of how bad it is. And of course, you want to report wall clouds, funnel clouds, and tornadoes to us. And we'll talk a little bit more about how to identify these after the break. All right, I know a lot of you guys have been asking about how to report severe weather to us. And there's many different ways you can report severe weather to us. One of the quickest ways and easiest ways to do that is by phone. Just give us a call here at 205-664-3010 and then press option 2. When you call, identify yourself as this trained storm spotter. Just let us know what you saw. Maybe a wall cloud with strong rotation. Where are you? That's important. Have 1 mile north of the leads. And, is this now? Is this 5 minutes ago? And we'll say, hey, thanks for your report. We really appreciate it. That's the quickest way to get reports to us. So definitely keep this number in mind. Other options are to contact your local emergency management office and law enforcement. But again, that's going to take a little bit of time for them to get the report back to us. So if it's less urgent, you can go that way. But for more urgent reports, there's a tornado, you want to call us right away. Another really quick way to report severe weather to us is through social media, especially Twitter. The easiest way to report severe weather to us is in a quick way is either calling us or using Twitter. Because during severe weather, we're going to be very closely monitoring Twitter for those reports. You can either tweet to us at NWS Birmingham. I hope you guys follow us too as well. Or you can use some hashtags like ALWX or hashtag BMXWX. That's a way to some other hashtags that we monitor. And in that way, media will see your reports as well, and they can help communicate that too. you don't have Twitter, you can also report to us via Facebook. It may take us a little bit longer to see your report, but still we want to hear from you. You can either send us a message or post on our wall. You can like us or follow us on Facebook at U.S. National Weather Service, Birmingham, Alabama. Another option is on our webpage. This is another option where it's a little less urgent. If there's a tornado, use Twitter or call us or something really urgent. If it's a little more of a delayed report, you can go on our webpage, weather.gov/BMX, and you actually want to bookmark that page as well, just because there's a lot of great info on that page from us. If you go to our webpage under current hazards, there's a link to submit a storm report, and that sets up a little like Google form or something that you can fill out, and then we'll get emailed about that to go check those reports. Another option is the Spotter Network app. That's a quick weather report on your cell phone. It's a pretty easy submission. It can include your GPS location and report form, so we know exactly where the report happened. These reports automatically come into our NWS chat room we have with our media and emergency management personnel. There is a separate spotter training that you have to take from them to be able to report. More information is at spotternetwork.org. Also, we have some really dedicated amateur radio folks from our alert group, and so when there's severe weather happening, they'll come right into our office and set up the radios, K4 NWS, and they'll relay those reports to us. And there's also a lot of amateur radio folks that are affiliated with the emergency management agencies. So if you're in the amateur radio, it's a great way to get severe weather to us. It's a way to report when a lot of different other communication lines are down. Amateur radio still works. Another option is to email your report to us. Now we want to, again, say this is not something you want to do to report severe weather if it's just happened, if the storms are still ongoing, because we may not see this right away. This is more for an after the event report. Maybe you didn't know about the trees that fell last night, but next morning you look outside and you see some trees down, or you're driving around, you see some trees down. You want to let us know. You can email us at sr-bmx.dss@noaa.gov. You can also send us some pictures. Love your pictures. Going back to social media, we love getting your pictures of severe weather damage and reports. It really helps us to get an idea of what happened, whether it's on Twitter or Facebook or email. A picture is really worth 1,000 words. Let's see, we got some more questions here. So we're asking about Coleman. So Coleman is actually covered by the Huntsville Weather Service office. So you'd want to report severe weather to them and get your warnings from them. If you're in that area, if you're down in Jefferson County or Blount County or Winston County, then you would want to report them to us. We don't have an official number of trained storm spotters. We just try to train as many people as we can, and we'd like to get all the reports that we can. Again, if there's some ongoing flooding, damaging winds that just happened now or the last couple hours, or a tornado, don't email us, call us, or use Twitter. All right, so as you can see, there's tons of different ways to report severe weather to us. Now, as you're storm spotting, we want you to remember that safety is always your primary objective. The safety of you and those around you is much more important than any storm report or storm photo. So, especially we talk about mobile storm spotting, storm spotting, you're actually out driving around. That's pretty difficult in Alabama when you got a lot of trees, more traffic, hills, and a lot of nighttime severe weather. So a lot of time you're going to be more stationary when you're storm spotting. You're at your home or work or church or somewhere. and just letting us know what you have. And then if a tornado's heading your way, go ahead, get to your safe place. Don't be standing out there watching for it, because you probably won't see it until it's too late. But when you are out around storm spotting or driving around in severe weather, you gotta remain very aware of the situation around you. Don't just get focused on the one storm. Make sure you know where other storms are, what the weather's like. Keep an eye on the road, the traffic. You don't want to be driving down the road, also looking at the storm and looking at the radar on your phone, because that's, of course, very dangerous. Also, you need to heed all road closures. Be a storm spotter does not give you a license to drive around barricades or not obey law enforcement. Definitely have to obey all those rules as well. Don't be speeding or breaking other traffic laws. Also, if you are mobile storm spotting, make sure you have an escape route. If something goes wrong, you need to know where the roads are and be able to have a road you can drive down to get away from the storm if you need to. So make sure you know which way the storm is moving and keep a safe distance. Spot with a partner. Really good at an extra pair of eyes to keep an eye on the road for you. If you're driving, you want your partner to be watching the storm, not you, so that you're being safe. And just, an extra pair of eyes. Avoid the most intense part of the storm. Never try to be out storm spotting at night. It's just way too dangerous. You're not going to see anything. Also, don't be storm spotting in urban areas. You don't want to be trying to drive around on 665 or 280 and get caught in a traffic jam when the storm's coming. And avoid being too close. Again, always obey traffic laws. If you are out storm spotting, never stop or park on the roadway. That's, we see that a lot in the Great Plains with storm chasers blocking roads or being too close to the road. It just becomes a big safety issue. Also, don't get tunnel vision when you're storm spotting. There may be dangerous weather elements other than the one you're focused on. Surprises happen. Maybe focused on one storm, one tornado, when another one's popping up behind it. You may be focused on, wind or tornadoes and forget about the flooding risk and drive right into some floodwaters. Also, things like lightning. You don't want to be standing outside in a thunderstorm spotting because, if there's a chance of lightning nearby. All right, our last section before the break is going to be on weather safety. Often overlooked area of weather safety. Everybody worries about tornadoes and hurricanes when they should be more worried about lightning. Lightning is very common in central Alabama. Comes all months of the year, especially in the summer. And lightning can and is deadly. Unfortunately, there's still many people struck by lightning each year that lose their lives. I've seen many times where I'm out and about in the summer, and people just keep going out throughout their activities, and there's lightning around. Lightning can strike as far as 10 to 15 miles away from a thunderstorm, so it does not need to be raining where you are for you to be struck. It could be sunny where you are, but the storm is nearby. There could be a lightning bolt. This picture here shows this lightning bolt coming right out of the side of the storm. Whenever you can see lightning or hear thunder, now's the time to go indoors in a building. Avoid appliances and metal surfaces. Cars are a safe place from lightning, so go ahead and get in those. Roll the windows up. As long as you're in a hardtop vehicle, a convertible would not be safe for lightning, but the metal-friendly car would redirect the lightning around you, so your car is safe from lightning. Now, if there's no cars or buildings around, you kind of have a tough decision to make. And hopefully you're weather aware and don't let yourself get into the situation. But if you are caught outside without shelter, you want to crouch down low, but don't lie flat. Basically, make yourself a low object, but also minimize contact with the ground because the electrical charge can go through the ground. You don't want to stand near tall objects. You don't want to be in any bodies of water. elevated areas, or objects that can conduct electricity. Let's see. Someone asked about the danger of cloud-to-cloud lightning. Now, the cloud-to-cloud lightning may not be dangerous in itself. If a storm has cloud-to-cloud lightning, it has the potential to produce cloud-to-ground lightning. So, whether you see the lightning in the clouds or in the ground, you still want to move inside. Another often overlooked weather safety item is flooding. Flooding is a leading cause of weather-related deaths in the U.S. Again, people aren't concerned about it. They think, water is something we know. We go to the beach, we go swim in the pool, take a shower in water. We don't realize how dangerous water can be when there's flood water. So never cross water-covered roadways. We always tell people turn around, don't drown. Even if it doesn't look like it's that deep, the thing is you don't know what's underneath the surface of the water. The road could be washed out or compromised in some way. There could be the water could be a lot deeper than you think it is. Could be an area, yeah, I drive this road every day, it should be fine, but you never know, what happened to the road or what other hazards are in there. There could be ditches that you don't see, and you may not know where the road is, so you may end up driving off the road into the ditch into much deeper water. Always move to higher ground. Roads are closed, barricaded, and never drive around those barriers. And be especially careful at night, because at night it's really hard to see flooded roads. You definitely got to slow down. So you'd be surprised if water is flowing quickly. It does not take much water at all to carry away a person or a vehicle. It only takes 6 inches of fast-moving water, just 6 inches, to knock over and carry away an adult. Only takes 12 inches, 1 foot of fast-moving water to carry away a small car. Even, your large SUVs, vans, and trucks, 18 to 24 inches, 1.5 to 2 feet, and all of a sudden your SUV is a boat. And the thing is, you think, oh, it's only a foot deep, so I'm okay, but do you ever really know how deep the water is? Again, the road could be washed out, you may not know where the road is, you may end up in the ditch. You just never know how deep that water is, so just don't even try. All right, so we got a video here. This person was in their pickup truck out in the Carolinas from a recent hurricane. This road was closed, but he decided to keep going anyway because he had a truck. And it didn't take long until his truck is a boat and he's floating away. I believe this person was okay, but a lot of times people aren't okay in the situation. So go ahead and watch this video one more time. Again, that water is flowing. It's moving quickly in that river. And so, the water isn't even covering his wheel wells up, and he's already floating. And problems with this, at that point, you're not just putting yourself at risk, you're putting, anyone else in the car with you at risk, whether it's your friends, family, kids. And you're also putting the lives at risk of the emergency responders. And someone's going to have to go try to rescue you, and now they're putting their life on the line for you. So turn around, don't drown. All right, we've already talked a little bit about this, but tornado safety. So turn around or have good insurance. Well, insurance won't help you if you're dead. So for tornadoes, a basement or underground shelter is ideal, but most of us don't have basements in Alabama, don't have storm shelters. Thing is, 99% of the time is you're going to be fine if you just get an interior room on the lowest floor of a sturdy building and cover yourself. So put as many walls between you and the tornado as possible. So in your house, you want to think about, okay, do I have a closet or a bathroom that's in the middle of the house, doesn't have any exterior walls or windows, it's on the lowest floor. You want to avoid any large or open rooms. You don't want to be in a big auditorium. You don't want to be out in the aisles at Walmart, because those can collapse pretty easily, or any type of gymnasium. Avoid windows. Now, getting into the lowest floor interior room, that works if you're in a site built home. But if you're in a mobile or manufactured home, that's not a good option. You want to actually get out of the mobile home and find more substantial structure. But you don't want to be waiting until the tornado's bearing down you to try to find a better shelter. You need to remain weather aware, whether that's when the watch is issued or if you see a storm that's one county away from you. Try to get to know your neighbors that might have a place to live. Because we're finding out is the problem with these mobile homes that they just really aren't anchored well to the ground. So even if they seem sturdy, they're just, again, not well tied down to the ground. So they, tornado lifts them up and just tosses them. That becomes very dangerous at that point. Another bad place to be in a tornado is in your car. You never want to be in your car during a tornado because that can send your car airborne, and there'll be flying debris coming at you. You want to find shelter. Okay, so what do I do if I'm in the car, but there's no nearby place to go to? If you're in a car, you want to try to get in, knock on someone's door, see that they'll let you in. Try to go to a business. If that's not an option, well, first off is you want to be weather aware so that you're not caught in making that decision. Know beforehand, hey, there's bad weather coming. I'm not going to be out in my car. I'm going to be somewhere safe. If you are caught out in your car, there's really no good options, just some last resorts. Your options are to get in a ditch, lay flat, get out of the car. You could kind of crouch down in the car. Again, that's just not a good options. Don't let yourself get caught in that position. Also, never try to go underneath a bridge or overpass. That's another common misconception. The winds are actually faster underneath the overpass. That's going to be more dangerous. Let's see. Yeah, some great points here. People get in the bathtub. That's great. Put a helmet on. Cover yourself with mattresses or pillows, blankets. Brick homes versus wooden homes. I'm probably not qualified to answer that, but any kind of site-built home is going to be fairly safe from the vast majority of tornadoes. Now, EF4, EF5, even in site-built homes, can be fatal. But again, those are pretty rare, and even with those tornadoes, it's a very small area that's actually hit by the highest winds, and you're still improving your chances greatly by just getting that lowest floor interior room. Just think of how can I get to a better place for me and my family. And the whole point of this is, have a plan in place. What are we going to do in our family? Take shelter, and how are we going to get these warnings? And so right now is the perfect time. We're getting to the peak times for weather. So tonight, after the class, start thinking through this plan. So you also need to have multiple ways to get severe weather alerts. You don't want to rely on just one thing. We always want redundancy because one-way alerts is probably going to fail at some point if you just rely on one thing, no matter how good it is. You want to have multiple ways and backups. It's your life at risk. It's your family's life at risk, and so you don't want to take any chances. And you also need to make sure you have ways to get weather alerts that can wake you up when you're sleeping. You also want to make sure your weather information comes from a reliable and credible source. Weather radios are still one of the fastest ways to receive watches and warnings. They're pretty inexpensive. We're talking $25, $30 at your local store. Pick those up. It's just as important to have that in your house as you would a smoke detector. Hopefully you wouldn't live in a house without a smoke detector. So I hope you'd be the same way. I don't want to live in a house with a weather radio. So it costs a little bit, but it's the cost of a couple fast food meals to get this. And you can program these weather radios to only go off for your county, so that you're not getting alerts for counties that don't affect you. The weather radios that go off, they're pretty loud when they go off. They're going to wake you up in the middle of the night. But you don't want to just rely on those. Other good options are different weather apps out there. There's a variety of apps out there. Just do your homework when you're looking at weather apps. Check and see, is this to use official National Weather Service warnings? Is it Polygon based? Do your homework on that. Also make sure that wireless emergency alerts are turned on your phone. Many smartphones now have the capability and you may have heard them go off before, or if you're in the near the warning polygon, that'll go off. A lot of county emergency management agencies have started to set up their own alert systems that you can sign up. So check with your county to see if you can sign up for an alert system that can, call or text you or email you with alerts. And a lot of those, they're not just going to be for weather. They may alert you for things like a chemical spill nearby or some other hazardous situation. Don't just rely on the outdoors tornado sirens. For one thing, they're outdoors. A lot of times you're not going to hear them in your house. If you're inside, you got, of course, we're talking about the kids are making noise, the dogs are making noise, you're watching TV, playing music, or you're sleeping, you're not going to hear the tornado siren unless you're right by it. So don't just rely on sirens. Get that weather radio, those apps for your house, and monitor local TV and radio. Also, if you're in the storm spotter class, you're probably somewhat weather savvy. If there's three other that's coming up, text your friends, let them know it's coming. That's another great way to get info out. If you see the watches warning the storm's coming, post on Facebook, Instagram, text everybody, let them know that what's coming. You can be a great source for them as well. All right, we're about to take our 10-minute break here. I got some great info in the chat here. Go ahead and keep asking your questions. Otherwise, we'll get started back here in about 10 minutes, going into some cool pictures of tornadoes and thunderstorm structure. So we'll see you back here in 10 minutes. First, we'll talk about how thunderstorms and severe thunderstorms develop and different types of thunderstorms. Now, there are three basic ingredients we need to get a thunderstorm. It's kind of like cooking. You need to have all the right ingredients, and the different proportions of the ingredients, how much you put in, determines what you get. First ingredient is a source of lift. We need air to be rising in the atmosphere. As you see, those towering cumulus clouds kind of start rising. Air rises and cools, and eventually will condense into water droplets, and that's how we get thunderstorms. There's different ways to get lift. There can be fronts, things like cold fronts and warm fronts. Things like gust fronts or outflow boundaries, just that cool air rushing out from a thunderstorm. You hear I'll get a lot of those in the summer days. Air moving up terrain, upslope flow. Even with our even some of our foothills near Alabama, we can get some of that. And just surface heating. Summer, we get a lot of these storms on a summer day, which the heating of the day causes thunderstorms. We need moisture, of course. Otherwise, we wouldn't have any rain or storms. We got plenty of that here that comes from the Gulf of Mexico. We also need instability. Temperatures always cool off at tight, but if they cool off more than is typical, that's when the atmosphere is more unstable. So if we have warm, moist air at the ground and cold, dry air aloft, that gives us a lot of instability for warm air to rise. So fourth ingredient then that determines if storms are just going to be regular, ordinary thunderstorms like we get in the summer versus if they're going to be more severe organized storms like we get during our tornado season. And wind shear is the change in wind speed and direction with height that could help thunderstorms to become more organized and live longer and be more severe. All right, so there are three different stages in the thunderstorm life cycle, if you will. First is the towering cumulus stage, where you have just rising air, what we call the updraft. That's when you start seeing their cumulus clouds. They start taking on more of the cauliflower type shape, going from cotton balls to cauliflower, if you will. They start growing. Then the storm enters the mature stage. That's when the storm can be 40,000 to 60,000 feet tall. It has both a strong updraft, strong rising air, and a strong downdraft, strong sinking air. And it's in the downdraft where you have the heavy rain, large hail, some damaging winds. This is also the time of the storm when you can get tornadoes. Finally, there's the dissipating stage. At that point, air is pretty much all sinking. The downdraft has cut off the updraft. You get a little leftover rain and gusty winds, and you still want to watch out for the last lightning strike. That's going to be dangerous where you think the storm is over. There's one more lightning strike that could potentially hurt you, and you get a remnant anvil cloud left aloft. There's a kind of a broad, continuous spectrum of thunderstorm types. Obviously, nature doesn't always fit into neat little boxes. In general, there's kind of three main types: single cell, multi-cell, and supercell. And some of these types have different subtypes built in too. A single cell thunderstorm is what we get pretty much every afternoon in the summer in Alabama. It's just a storm roughly by itself. We see an example here. Now, there's another type of storm that's by itself, which is a supercell, and that's not what we're talking about here. We'll talk about that in a little bit. These are just these pulse thunderstorms that are just weaker. These are the ones that are more short-lived. They go up, they go down, they last 30 minutes or so, maybe an hour. They can appear relatively random in time and location. There's usually reasons why they form when they do, but they're a little more just scattered about. These storms often don't have a severe other threat, or if they do, it's pretty low and brief. They can still produce gusty winds that, even if they're not severe, they can still be gusty enough to bring down maybe a weak tree or some branches. They can produce small hail, and these can still produce heavy rain. And also, even though they're considered weaker storms, they can produce potentially deadly lightning. And also, they can almost be a little more sneaky in that way, because a storm with a lot of lightning you may think is more dangerous than storms with a few flashes of lightning. But these are the ones that can be actually get you because you're not expecting them to be as dangerous. Second type is what we call a multi-cell thunderstorm. You kind of have several storms that kind of form in a group. Each of them are in different stages in their life cycle. It's just kind of a conglomerate of single cells. There's several different types of multi-cell storms. The first we might just call the cluster. Just kind of storms just kind of popping up everywhere, close to each other. Also see a lot of these on summer days. We have just storms kind of all over the place. These storms can have a low to moderate severe weather threat, depends on your environment. They can produce heavy rain, which can be a problem with flooding if storms are kind of stalled or slow moving, or if the same storms kind of move over the same area over time. Gusty is sometimes damaging winds, small to sometimes large hail, and deadly lightning. Another type of storm is what we call the multi-cell line or a squall line. Now, these are storms more an organized line that's moving, often very quickly. These can have a low to high severe weather threat, depends on the environment. You see here, more continuous line of storms that are moving with some strong winds. Yeah, these can have gusty to damaging winds, weak to strong tornadoes, small to large hail, some heavy rain, especially if the line is slower moving or cells move parallel to the line and kind of train over the same place, and lots of lightning. You also will see a shelf cloud with these storms. We'll talk about what that is in a little bit. We actually already talked about this earlier, but powerhouse long track squall lines are called derechos if they have damaging winds over a track that's 250 miles or greater. The final type is the supercell thunderstorm. That's the one we're going to talk about the most today because, well, these are actually the rarest type of thunderstorm. They're the storms that produce the most severe weather and tornadoes. The key thing of these storms is, they may be by themselves, maybe in a line. The key thing here is that the whole storm is rotating. The updraft, the area of rising motion of the storm is rotating. You can kind of imagine it kind of a helical fashion. You might see a sculpted, like kind of barber pole shaped updraft. Again, these are the strongest severe thunderstorm type because they can last a lot longer and be stronger than other storms. High severe weather threat. These can produce weak to strong tornadoes, sometimes along track, large to giant hail, damaging winds, heavy rain, flooding, and lightning. Here's a side view of a supercell thunderstorm. Key thing here is that we have a rotating updraft. It's not just straight rising air. The air is actually rotating as it rises. Also, the updraft is tilted as you go up. What that means is that your downdraft, your area of sinking, cool air, has a lot of heavy rain and hail, is separate from the updraft. In a more like single cell thunderstorm, the downdraft is going to fall right on top of the updraft and just kind of squash it, and that's why those storms won't last very long. In this case, the downdraft is separate from the updraft, so the updraft can still keep feeding on that warm, moist air. Warm, moist air is just the fuel, the gasoline for these storms. And it has access to that while the downdraft doesn't cut it off. Now, underneath the updraft, we'll talk about a little bit later, it's actually where you want to look for the wall cloud and tornado. Even though the downdraft may look worse and more ominous, it's darker, actually it's kind of right on the border of the lighter and darker air, the updraft and downdraft, where you can look for the wall cloud and tornado. Now we kind of break up supercells into a couple different types. First is the classic supercell. In this case, the rotation and visible updraft is visible. You can see it clearly. We have what's called the rain-free base. We can see an area of the storm where there's not too much rain falling underneath. And that's where air is rising to the storm versus the downdraft is over here, the darker area. Now, it's possible that some of this rain could get pulled around the updraft over time, so that it would be hard to see the updraft and become more rain-wrapped as the storm eventually turns into a HP or high precipitation cell, which would be the next slide. We do see this in Alabama. They're not the most common type, but still fairly common. The radar signature is a pretty classic kind of kidney bean type shape with pretty clear hook echo showing up. If you look at storms and watch tornado coverage, you're probably pretty familiar with seeing these. The second type of supercell is what we call the low precipitation or LP supercell. This usually happens in drier climates where their updraft and rotation is highly visible, There's a lot less rain or hail, right, or very little, if any, rain and hail. You may not even be able to see the Hokkaido on radar because there's no rain for it to pick up. These are the most picturesque type of supercells, but also very rare in Alabama. These happen typically in drier climates. You see these out in the Great Plains, especially the high plains. So areas like Colorado, New Mexico, West Texas, Western Kansas. Not going to see these too often in Alabama. We're obviously, moisture is never a problem for us. We're usually pretty humid, moist, being near the Gulf of Mexico. So we don't see these too often. What we do see a lot is the high precipitation or HV supercells. In that case, these are what we call rain wrapped. The updraft and rotation is really hard to see because there's rain all around it. It's really hard to make out features. It's really hard to tell where to even look for a tornado in these storms if you can't see it. Very dangerous for spotters. It's really hard to see what's going on. These are very common in Alabama. It's really hard to actually see the tornadoes in Alabama because they're rain wrapped. You may not even be able to see the hook echo and radar. You may need to rely on velocity data to see the rotation. So again, these are much more dangerous because it's going to be hard to see what's going on. You won't see the tornado until it's right on top of you. Kind of recapping these supercell types. Classic supercells, the updraft and the tornado, if there is one, is visible, but could become rain wrapped with time. LP or low precipitation supercells, the updraft and tornado, if there is one, is highly visible through its life cycle. And the HP supercell, high precipitation, the updraft and tornado, if it's occurring, is rain wrapped. Another kind of bonus type of supercell that we do see often in Alabama is what we call the mini supercell. Supercells are just like mini supercells, are just like regular supercells, except they're all shrunk down in size. They're a lot smaller horizontally, much shallower, not very tall vertically. These are common both in tropical storms, hurricanes, and also in a lot of these cool season weather systems. This time of year, February, kind of winter, early spring, we see these a lot. These are mini supercells. They look pretty nondescript on radar, but they actually have a lot of rotation in them. They can either be embedded in a large area of rain or discrete. Now, the severe threat is typically not as significant as regular supercells, but these can and do produce low end to sometimes even strong tornadoes. The main threat with these is usually tornadoes. The threat of damaging winds and hail is low. These mini supercells can produce very little or no lightning. It's actually possible to get a tornado with one of these mini supercells with no lightning at all. It's definitely a challenge with these events. Again, these a lot of times are going to be at night, during the winter, early spring, late fall, and also with our tropical systems. All right, now we're going to do thunderstorm structure, things like wall clouds, shelf clouds, funnel clouds. Starting off, we talked about supercells. They have a rotating updraft where the air is spinning as it rises. The whole storm is actually spinning. And that's what we call the mesocyclone. It's not the tornado. The tornado is much smaller. This is the whole storm scale or area of deep rotation. And sometimes you can actually see the curvature in the whole storm. Now, this picture here was taken somewhere out in Kansas or somewhere out in the plains. So it's a lot easier to see the structures. In Alabama, again, we have lots of rain, a lot of rain wrap things, a lot of extra clouds around. It's going to be hard to see this most of the time. In this case, this is where the warm, moist air is feeding into the updraft. You might see some striations. This is the area we're most interested in looking at because this is where the wall cloud, funnel cloud, and possible tornado could occur. Now, plenty of storms have rotation, mesocyclones, that don't produce tornadoes at all. So it's definitely not a guarantee, but most tornadoes do come from these. Also be careful, we talk about this rain-free base where the air is rising, keeping the rain from falling, and that's where we want to look. But we have to be careful because ordinary thunderstorms can have rain-free bases as well. The key thing is the whole updraft has to be rotating and be called a mesocyclone. And again, not all storms will visually have a clearly defined mesocyclone because of all the extra clouds and rain around. All right. Next up, what you want to look for is the wall cloud. The wall cloud is much smaller area. It's a localized lowering of the cloud base. Now it has to be attached to the main storm cloud. A lot of times you might see different low clouds around, and if it's not actually attached to the cloud, to the main storm cloud, it's not a wall cloud. It's just a scud cloud or a random cloud. So again, these are attached. They're persistent. It's not some short-lived thing. It sticks around. It's kind of blocky. It's not much wider than it is tall. It's more localized. It's an area where inflow is occurring to the storm. It may exhibit rotation, upward motion if beneath the mesocyclone. Now, not all wall clouds rotate. So you just keeping that in mind. If you do see rotation, you definitely want to let us know. And most rotating wall clouds won't produce a tornado. So just because you have a rotating wall cloud does not mean there'll be a tornado. Not all storms are going to have a clearly defined wall cloud that you can make out visually. All right, so these clouds, they look pretty ominous. As you see some low-hanging clouds. Man, this looks pretty bad. I better call the National Weather Service to tell I've got a tornado. Actually, these are what we call lookalikes. Neither of these pictures are of tornadoes, but of just scud clouds. They're kind of they fake you out. Sometimes we'll call them SLCs, scary-looking clouds. Key thing with these is they're usually unattached. They're not actually attached to the cloud base. They're just kind of floating by themselves. They're very ragged. You don't see smooth edges. Typically, if something's rotating in a tornado, it's going to be much smoother. If they're really raggedy and jagged looking, they're probably just the scud cloud and pretty harmless, actually. They're formed by the interaction of rain-cooled air and surrounding warm air within a humid low-level air mass. Key thing with these is they're not rotating. And if they're not rotating, they're not a funnel cloud and not a tornado. They're harmless. Don't get tricked. You go ahead and let us know. I see a scud cloud, but just be very careful not to call these funnel clouds and tornadoes. Now, sometimes scud clouds will form near and rise into a storm's updraft region, leading to the formation of a wall cloud. This is in case the storm is organizing, and so you want to watch for further development, increasing vertical motion, and any rotation. Let's see, I had a great question here about difference between mesocyclone and tornado. It's really about scale and size. Mesocyclone is much bigger. It's the whole storm. It's miles wide, whereas a tornado is going to be much smaller. Less than a mile wide usually. Another thing that, again, is an ominous kind of tornado lookalike is a tail cloud. Key thing is these are kind of horizontally oriented, bands of inflow feeding into the wall cloud for the main rain core. You see they kind of point towards the area of heavy rain. They're ragged. They're also not vertical. Now, these can develop pretty close to the ground. They may look pretty scary, pretty ominous, but don't get tricked. Don't get fooled. This is not a funnel cloud or a tornado. Now, another key thing I want you, if you don't remember anything else today, is to remember the difference between wall clouds and shelf clouds. This is a very important, one of the most important things we talk about today. A lot of times we get reports of wall clouds when actually it's just a shelf cloud. Shelf clouds happen on the leading edge of the gust front, or that area of rain-cooled air that rushes out ahead of the thunderstorm. Now, it can be pretty low-hanging. Key thing here is it's horizontal, and it's also very long, typically much wider than it is tall. A lot of times we'll see these covering the entire sky. A wall cloud is going to be much smaller in size than a shelf cloud. These are very frequent. You see these a lot. They can occur with squall lines. These can indicate you may have some gusty winds, maybe damaging winds, so definitely keep an eye on them. But typically, you're not going to have tornadoes with these. Another key is that these slope away from the rain area. They slope towards the clear air whereas wall clouds are going to slope more towards the rain area. Again, you may see little things hanging down from the cloud, turbulent eddies on the edge or underneath them. But they're not associated with anything tornadic. So the arrows here, what's happening are actually just trying to tell you what the invisible air currents are doing. So you got invisible warm air that's riding over top of some cool air. You know, this comes in, the wind's going to pick up, and you're going to have a temperature drop. On a summer day, this actually is a good way to get a nice cooler air, a little bit of relief from the heat. But you also want to be careful with the lightning and the winds as well. So let's recap wall clouds versus shelf clouds. One of the key things here is just think about, okay, what part of the storm am I looking at? Shelf clouds are usually associated with downdraft. Wall clouds are more updraft by the downdraft, but more by the updraft. So again, wall clouds are associated with updrafts. Shelf clouds are associated with downdrafts. Wall clouds are associated with funnel clouds and tornadoes and are favorite areas for rotation. Shelf clouds are not. A wall cloud is a low blocky cloud, while a shelf cloud is much more elongated, but still low. And we'll go over some more examples in kind of the quiz section to distinguish wall clouds and shelf clouds. All right, now we're going to head towards maybe the most interesting part of the talk is tornado development. All right, so we've talked about the wall cloud. Once you have a wall cloud, then you want to watch to see if there's any funnel clouds. Again, these can be kind of tricky to know what's a funnel cloud and what's just look-alike. Funnel clouds are rotating. They have to be rotating. If they're not rotating, they're not funnel clouds. They're funnel-shaped or kind of cone-shaped usually. They extend downward from the base of a thunderstorm. And they're attached to the cloud base. Kind of an asterisk by thunderstorm is to mention that you can get cells that actually have no lightning but have tornadoes. Key thing here is that these are often pretty smooth or laminar looking. They're not ragged or jagged like some of those scud clouds we saw earlier. So they're smooth, they're rotating. The rotation usually is what makes them smooth. They're associated with the updraft. And the key thing, of course, funnel clouds are not tornadoes. The difference between a funnel cloud and a tornado is that funnel clouds don't reach the ground. Though there is a caveat, even with that, these are pretty challenging, is that the visible part of the visible part of the tornado does not have to reach all the ground to be a tornado. And we'll talk about that in a little bit. But if there's nothing happening on the ground, it's just a funnel cloud. Then finally, in rare instances, we get tornadoes. A tornado is a violently rotating vertical column of air extending from the base of a thunderstorm. Asterisk that sometimes storms have no lightning, but still tornadoes to the ground. And yep, typically funnel clouds turn into tornadoes. Tricky thing with this is the part of the tornado you can see, the condensation cloud, may not be condensed all the way to the ground, but still be a tornado. The key thing to look at is what's happening on the ground. Is there any debris, dirt, anything getting picked up by a tornado? If you see any kind of debris being picked up underneath the funnel cloud, that means that this is a tornado, not just a funnel cloud. So here's kind of the full evolution. We first start looking for this wall cloud, kind of localized lowering in the cloud base underneath the updraft. You know, we're seeing not a lot of rain underneath this. It's more rain-free base. Then we start getting a funnel cloud. Now here we got a couple other raggedy things kind of hanging down from the cloud, but those aren't anything. This right in the middle, this smoother cone-shaped thing, this is the funnel cloud that's smoother and rotating. And eventually we can get tornadoes. Of course, tornadoes come in all shapes and sizes. The ones that are wider can be a little more difficult to turn into a tornado, but typically you're also going to see some very fast winds. If you're seeing a lot of fast winds rotating close to the ground, that's very likely a tornado, a pretty dangerous one. Let's see. As far as I know, this is the same storm. The dates are the same. These were actually taken by one of our meteorologists doing some storm chasing out west. All right. Yeah, I think you asked for a video, so here's a video kind of showing the real world evolution of some features. Not totally sure if this is real time or a time lapse, but it gives you this general idea. So far, we have some evidence of wall cloud, which is kind of a localized lowering of the cloud base. A little bit of rain, but it's not a ton of rain, so it's more rain-free. Now, right now, we do a bunch of stuff that's kind of hanging down from the cloud, but it's all pretty ragged. None of it's really persistent, and so we're not seeing any kind of funnel cloud yet, but we are definitely seeing some rotation occurring. This is definitely something you want to call into the weather service of a rotating wall cloud. So asking about tornadoes identified by radar. Once the tornado is on the ground and actually picking up stuff on the ground, debris, that's when we can confirm it. If the radar can detect different stuff in the air that's not rain, is pieces of trees or shingles, and then that's when the tornado can detect it. Radar will also pick up, some of the rotation that leads to a tornado as well. So as we continue along here, see from the grass, the wind's kind of blowing into the storm. So we're in an area of inflow. So that warm moist air is coming into the storm. There's probably some more heavier rain downdraft off the camera here. And so far, the contrast is not the best, but you can still see just a wall cloud right now. A couple rain curtains. You also want to not be fooled by those. That's just rain. It's not actually any kind of funnel cloud. All right, zoomed out a little more, we can see this wall cloud right here. And it's still organized at this point. A couple other, scud clouds, kind of low-hanging clouds that are a little bit of an inflow band happening right here. And it's starting to get a little interesting in this part of the storm. Trying to remember exactly. I think actually right here you're starting to get a funnel cloud, a little smoother thing hanging out from the cloud, more cone shaped, and pretty quickly it comes down to the ground. And at this point we have a tornado. You can see there are some trees in the way, you can't see exactly, but if it's more than halfway to the ground, it probably is a tornado. And so we have a nice little cone-shaped tornado here. Can't really see debris being picked up. Of course, there may just be some open fields here, but pretty strong evidence of a tornado here. All right. We can also, again, we also look at radar to look for tornadoes. We can look for things like hook echoes and reflectivity. This is a more classic type supercell where it's pretty easy that if you're not a meteorologist, you can probably tell, hey, something's going on here. This is the velocity data. Our radar, I think, is up here. Winds are blowing towards and away from the radar. If we see winds blowing toward and away from the radar right close to each other really strongly, that implies rotation and strong evidence that a tornado is either occurring or it's about to occur, and we go ahead and issue the warning. Other times, though, and we see this a lot in Alabama, it's not as obvious where the tornado is. We'll give you these more embedded supercell tornadoes and line tornadoes, QLCS tornadoes. Now look here on the left, it's hard to tell what's going on here, if there's anything dangerous. Velocity, though, is showing some pretty strong rotation right here. All right, so after the tornado, we collect all the damage reports from our storm spotters, emergency managers, and others, and we determine if we have to do any tornado damage surveys. So in order to determine if a tornado happens and confirmed it, we actually have to go drive out in the field, drive down a lot of dirt roads, follow the path of the storm, and look at the damage and determine if it's associated with rotation and comparing it with the radar and then seeing how bad the damage is. It's pretty rare that we can actually measure the actual wind speed of the tornado. There aren't that many wind reporting stations, and it takes a lot of dumb luck to get a wind measurement. So most of the time we have to estimate the wind speed of the tornado based on the damage it caused. A couple of things to look at for tornado damage is we look for tree damage that is convergent with rotation. Ideally, you would see trees moving kind of lay in all directions, although the storm's moving pretty fast, you may not always see that. But if you do see kind of the trees pointing downstream towards the middle of the track, that's indicating some low pressure. So again, if the trees are kind of pointing towards the middle of the track in a very focused area, typically a relatively narrow swath, that's pretty easy to follow a clear path. On the other hand, we can also have strong straight line wind damage or damage from microbursts. In those cases, it's usually a wider path, a little less focused, and a lot of times you'll see the trees just kind of point outwards from the center of the damage, indicating divergent damage when spreading out. So that's a clue. Here's an example of a more extreme example of a very strong tornado going through a subdivision and some of the after effects of that, and actually some of the debris being sent downstream. So we use what's called the Enhanced Fujita Scale, named after Dr. Ted Fujita, to rate tornadoes on how bad they are and estimate a wind speed. Starting off with the weaker tornadoes, EF0s, winds at 65 to 85 miles per hour. This is damage, but it's relatively minor. We have some trees down here and there. We may have some shingles blown off, a little bit of parts of a roof peeled off, damage as gutters and siding, branches broken off from trees, some sporadic tree damage. So we move up into the EF1 category, 86 to 110 miles per hour. You start seeing some more significant roof damage, but at least in a well-built home, most of the roof is still intact. But windows can be broken, exterior doors damaged or lost. Pretty clear, a lot of trees snapped off, pretty clear damage path. And the reason we tell people to get on mobile homes is that even with a so-called weak tornado, just an EF1, mobile homes can be overturned and damaged and destroyed. And I think even had just a couple weeks ago, we had an EF1 tornado where someone did lose their life in a mobile home, just because there's nothing really holding the mobile home to the ground, so it just kind of goes flying and becomes very dangerous at that point. Let's move up to EF2 tornadoes. Going to be more rare. These are what are considered to be strong tornadoes, EF2 and above. You get more damage, roofs off of well-constructed homes. Homes can be shifted off the foundation, but most of the walls are intact. At this point, mobile homes are totally destroyed. Trees just kind of mowed down, cars tossed. EF3 damage is winds of 136 to 165 miles per hour. Getting into some more high-end damage here. The second story of your home could be totally destroyed. That's why we say get on the lowest floor if you can, because the second floor could be totally destroyed, but the first floor is still fine. You get some of the exterior walls falling in the house, but usually the interior walls are fine. That's why we say get in that interior room. Now, we also have to look at how good is the foundation. Was the home connected to the foundation well? If the home was not well attached to the foundation or is a weak foundation, the whole entire home could be blown away. We also see bark coming off of trees. So in EF4, now we're getting to what we call violent tornadoes, 166, 200 miles per hour. This is what the rating was for the Lee County tornado this last spring. At this point, even well-constructed homes are leveled. All the walls are collapsed, but there's usually still some debris left on the foundation. Cars thrown significant distances. Start seeing top story walls of stronger buildings collapsed. Just some really bad damage. EF5 tornadoes have more than 200 miles per hour winds. These are the rarest and most strong tornadoes. We saw a lot of these on April 27, 2011. At this point, even with a well-constructed home, the homes are swept away. and there's just an empty slab left over, and a lot more damage to those stronger buildings and high-rise buildings. Trees are debarked, stripped of branches and snapped. In some extreme cases, even pieces of blacktop can come off of roads. Really incredible damage at this point. All right, so that is most of the material we're going to go over tonight, but we do have what we call the report what you see photo polls. So basically, as we go into this, I'm going to show you some pictures of a feature and use the chat bubble feature and type in your answer, and we'll see if you're right. All right, here's a little animation. Go ahead and report what you see in the chat room. Get that animation going. There we go. All right, so it can be a little hard to see what's going on here because there are some trees in the way, as we often have trouble with. But we have clearly something that's rotating, extending down to the ground or almost to the ground. So this is a tornado in this case because you have the rotation basically all the way to the ground. All right, here's our next one. All right, so we see a lowering of the cloud base in this area right here. Pretty localized. It's not covering the whole sky, so it's not a shelf cloud. It is a wall cloud. It's also occurring kind of in between the updraft and downdraft, the clear air and the darker air. There's some evidence of rotation. We really can't say for certain what's happening underneath it. There's these trees in the way, just like as you often see in Alabama. So all we could say conclusively for our report would be a wall cloud. We really can't see any kind of funnel cloud or tornado. All right, report what you see. All right, so we do see a lowering from the cloud. It's pretty smooth and kind of cone shaped. In any we have at least a funnel cloud here. Now we don't see the funnel cloud kind of condense all over the ground. The tricky part here though is we do see, and I apologize for the quality on this, there does appear to be some debris actually being picked up on the ground. And so even though the visible part of the cloud doesn't go all to the ground, this is likely a tornado just because we're seeing something on the ground that's rotating and lifting stuff up, and so there actually is a tornado, even though we don't have condensation all the way to the ground. All right, this is more of a still image with some arrows. Let's report what you see. All right, so again, we see a lowering of the cloud base. However, so you might be tempted to call this a funnel cloud or something, but the key thing here is it's not rotating. It's also pretty raggedy and jagged. It's not very smooth. and there's some rising air. So this is part of the updraft. That's the acceptable answer. And it also says it's a scud cloud. So it looks ominous, but it's actually pretty harmless in this case. Just some harmless scud with an updraft. But you still want to keep an eye on it in case something changed. All right, next up, report what you see. All right, so we have some very strong rotation extending all the way to the ground. So this is actually a large wedge tornado. It's hard to see with this on the trees, but we're seeing very strong rotation extending at least as far down as we can see. If we saw this, we definitely want to get to our shelter right away. Of course, for this video, it'd probably be very obvious that there's a very violent rotation going on. So this is a tornado. All right, report what you see. Yep, great job, everybody. We do have some hail here. It's a great picture. If you send a report to us, is you take a picture of the hail and a known object, so we know exactly how big it is. And this is a quarter here, and quarter-sized hail is severe. Actually, some of this hail is probably a little bigger than quarter, so we definitely want to report this to us as being at least quarter-sized hail and severe. Actually, it is more like $50, actually, as some people said. All right, report what you see. And if you think different pictures are different things, you can let me know that too. All right, so some of these pictures are a little hard to tell. Here we definitely have a lowering from the cloud. It's smooth, likely rotating, pretty cone shaped, so it's not just scud, it is a funnel cloud. We're not seeing evidence of anything on the ground. I don't see any sort of debris or anything being kicked up here. And it only extends about halfway the ground, so this is clearly just a funnel cloud. Here it's also hard to tell. We can't see the ground in this picture. So at least from just this, I would say probably just a funnel cloud, can't see. Here, we have some trees in the way. Nice and smooth rotating funnel, and this extends more than halfway the ground, and probably a good chance it is a tornado. You may, if you're reporting this, say I'm not totally sure because of the trees. Also, a lot of these things, if you're not sure what you see, go ahead and snap a picture and send it to us, and we can help make an evaluation too. All right, report what you see. Yep, great job, everybody. That's this thing going down the ground, but the key is we're not seeing rotation or rising motion. We're seeing sinking air. This is a downdraft. There's some rain and maybe some hail here, and it's kind of spreading out of the ground. So there probably is some strong to damaging winds, and this definitely looks like a microburst. All right, report what you see. right, and you guys are right. This is a shelf cloud. It is not a wall cloud because you can see it's much wider than it is tall. It's covering the whole sky. It looks pretty ominous, but yeah, there's really not any signs of any rotation or tornadoes with this. This would indicate potentially some strong to damaging winds, and this is a shelf cloud. All right. I'm going to recap some of our spot information and then talk about what you can do for your storm spotter certificate. All right, so reviewing what makes a storm severe. If a storm has wind gusts of 58 miles per hour or greater and or hail 1 inch or more in diameter, it is severe and a severe thunderstorm warning is issued. If there is also a tornado with the storm, then it is severe, but we'd issue a tornado warning instead of a severe thunderstorm warning. Tornadic storms can also produce damaging straight line winds and large hail. Know your weather terms. Wall clouds are a low-hanging, blocky cloud in the storm's updraft. Some wall clouds rotate, others do not. If rotating, watch for possible development of a funnel cloud and tornado. Tail clouds are a low-hanging cloud that angles or feeds into the wall cloud. They're not dangerous, so they may form pretty low to the ground. Scud clouds are fragments of clouds hanging beneath the storm's base. They may be rising to the storm but don't rotate and are harmless. They may collect to form a wall cloud if under the updraft, so keep watch. Funnel clouds are a rotating, funnel-shaped cloud descending from the base of a thunderstorm. A funnel cloud does not touch the ground. A tornado is a violently rotating vertical column of air in contact with the ground. The key thing is there's rotation, even if you can't see it. Tornadoes, I mentioned earlier, tornadoes, ultimately are wind, which you can't see wind. You can only see the effects of wind. That's why there can actually be a tornado on the ground without the visible funnel, because that has to do with how strong the tornado is and if there's any condensation happening. Shelf clouds are a low, long, horizontal cloud associated with the storm's cold outflow. You may see turbulent motions along and under the shelf cloud, but do not mistake this for something tornadic. Straight line winds are the threat. And just keep in mind, as you're trying to report what these are, think to yourself, does this make sense? Is this in the right spot of the storm? And be sure before you report. Recapping how to report severe weather to us. A lot of different ways to do it. The quickest, most urgent way to do it is to call us, 205-664-3010, option 2. You can also call us if you have questions on the forecast. We answer that phone 24/7, just trying to serve you with the best weather information there is. You can tweet to us at NWS Birmingham on Twitter or hashtag ALWX, hashtag BMXWX. Facebook, Spotter Network, Ham Radio. Our webpage, weather.gov/BMX. Email us at sr-bmx.dss@noaa.gov. Just don't use email for the more urgent reports. All right, you definitely want to write down this link here to our Skywarn Storm Spotter page, weather.gov/bmx/Skywarn schedule. You can download a PDF copy of our Storm Spotter presentation that you can review. See a schedule of upcoming classes, lots of other training materials, brochures, and guides. Another web page to write down is weather.gov/bmx/spotter training. The way we handle storm spotter certificates is it's kind of self-service, kind of honor system. You go to this web page, it's a PDF, and it's optional if you want to do this, but if you want to have a storm spotter certification certificate, you go on there, print it out, and sign it. Also, we are trying to start up a database of trained spotters. You can go sign up on there. I think it's also a way to get an email certificate, but that's a way that, we're trying to figure out if there was some severe weather in your area, we could possibly contact you just to get severe weather information. We wouldn't contact you for any other reason except to know about weather information. let's see. I'll get back to that link in just a second. Also, if you like this class, but you felt like you wanted to know more, you want some more advanced knowledge of storm spotting and just the meteorology behind storms, you're in luck because we do have our advanced storm spotter class coming up Thursday, April 2nd on 6:30. It'll be online on Join Me, just like this one. We'll go over some structures of weather systems, low and high pressure, fronts, troughs, and ridges. Just geeking out on severe weather. Talk about parameters, satellite and radar analysis, soundings. We'll do some analysis of a real-life severe weather event, so you can see what we look for when we're forecasting and warning for severe weather. So yeah, this is definitely a great educational, or just you're interested in knowing about storms. Yeah, check out the advanced class. All right, let me go back to the links here. Weather.gov/BMX/Skywarn schedule. And I can type this in chat too, or weather.gov/BMX/spotter training. I'll be hanging out here for a little while for questions. Just want to thank you for attending this class. Any questions, just let us know. Also, if you're watching this with a group of people, if you could just let us know how many people are in your group watching this, just so we can keep track of how many people are attending. If you think of a question later, here's my email address, jason.davis@noaa.gov. I'd love to hear from you. Otherwise, thanks and have a great night.